Hello guys, so today I wanna solve a bit more complicated problem. Unlike in the other videos, this is not an interview question as far as I know, but it's a nice complicated enough problem that I really like, so I want to try and show you how to solve this problem. So the problem is when you press solve it, so this is the problem. You are given some sort of a lake, some sort of a map with green areas and white areas. White areas are lakes, and our problem is to find when you are given a coordinate, for example this one 2, 1, to find the surface area of the lake under that point. Or if the coordinate is green field, then return 0, because there is no lake there. So this problem should use some flat fill type of algorithm to, when you click the point, like when you touch the point, you fill all the area around it and calculate the size of it. And I'm using coding game here, so we can also check our solution if it actually works immediately. So let's start by copying their code here in our flat fill problem. Let's create a project. Okay, first of all enable hackerman mode. So console.foreground color equals foreground console equals console color dot green. Okay, and let's parse our inputs. So this will be a width, and this is the height. Oh, by the way, I have one sample here on which we can test it out. Okay, this is width, this is height. We don't like the warnings, so we will just make them disappear like this. And based on the height, we will get the map here, and this will be coordinate count, and here we'll need to parse each coordinate. So let's start off by creating some classes. So let's say models. We will have a coordinate. Let's first put in coordinate because it's a simple one. And let's not even make it a class, because we need some immutable object that is a coordinate. Let's call it just an struct instead of a class will be fine. And as we like to parse things in previous videos, let's do it here as well. So public static coordinate parse, and over our string input, and parts will be, so we know the coordinates are given to us in this format, like with a space between. So parts will be input dot split by space. Okay, and our x will be int dot parse parts of 0, and y will be, okay, we need to return new coordinate. We can make it like this, maybe just the so they are really immutable, and a constructor which takes in integer x and integer y. And in .parse for the x, let's call it small letters. Okay, and y is in .parse parts of 1. Okay, so we got our coordinate, and we'll simply just here first fix this and our coordinate count. So instead of using this, we'll just have our list of coordinates. Let's make everything a var, simply to be consistent. Coordinates equals new list of the coordinate, and use our models. Okay, and we will now make our coordinates by using coordinate.parse console readline, and this is some kind of default for a coordinate. Okay, and we just add the coordinate in, and now the points, now the map that needs to go in. So as you can see, already we are going by the height. This is telling us one thing: in the coordinates we will need to actually swap out the x and y. So this will be parts 1 and part 0. I came up to a problem while solving the task. It wouldn't work for some later examples because of the swapped x and y, so let's not get too much into this, why this needs to be swapped, but it just needs to be because the height is what we are going through for getting each row, blah blah blah. Anyways, now let's make a point map. So we need new class, let's call it point. And what does our point need to have? So each of our points can either be land or water. So let's make that boolean, for example, and let's say if it's water. Okay, and what else? So you can see that in this problem we will be using another concept, not just the breadth first search, not just the flood fill. We also have different lakes separated, right? So what we can do, when we solve each lake, we can give it some kind of identifier of its region that it's in, and by using that identifier we can easily get back the solution without flood filling again the area that we already solved. So we will call that public integer region ID. Okay, and for now that should be fine. We just now need to parse the point, public static point parse on the string input, but I think this will be actually a char, not a string, and we will just return a new point and it's water if input is equal to big O. Okay, simple as that. Okay, that should be it. Now let's make a map. So var map equals new point, and this will be two-dimensional array, which is width by height. I assume so. Let me check this out in the surface puzzle. Oh, actually it's height by width. Yeah, that's the thing I was talking about. So it's always reversed when you are reading from the console. You are reading by the height, and in each height you have a row of characters. In each, like one row, two, second row, third row, and so on. Okay, and now another loop by j, which goes over row that length, and let's create map of I and j equals new point, not new point, but point dot parse row of j. This should give us the proper points in a point map. Okay, so I think we already have our data ready. Let me see, we're already 12 minutes in. That feels like time is going by so fast. And now we need something to solve this. Let's make the folder name tools and the class name solver. I don't know what would be the proper way. I used to work in a professional environment, so we would have interfaces, services, stuff like that. So I'm kind of models, views. So I don't really know what would proper naming for these would be for stuff like that, like problem solving. But let's call it tools.solver. Okay, and let's make a constructor in which we will send all the data that we need. And we need private read-only, integer for width, we need a height, we need a map, only point, not just a drawing, but our point array, which is map, with only list of coordinates, which will be coordinates. Okay, I will send everything in the constructor: width, height, point array, map, and list coordinates. And I will say width equals width, height equals height, coordinate equals coordinate, map equals map. That's nice. We can leave it like this, doesn't really matter. Okay. And then we want a sol method. What should our sol method return actually? It's not a void for sure, but for each coordinate we need to return an integer. So We could make it like list of integer, but what I like more here is if we use enumerable instead. Why? If you know, so in enumerable you can yield return each element like this. So this kind of fits our problem. So for each coordinate we will yield return a single result. Okay, and let's just yield return break here so that doesn't have any errors. And now a private method which will be called search, private integer search, and we search over our coordinate. And so now for each item in our coordinates we will try to search that item, okay, and yield return it. Okay, so what's our logic here for searching? So if the coordinate is, so let's not look at it like this way, but let's just let's first make a point. So starting point equals map on the coordinate dot x and coordinate dot y, and let's check if our starting point dot water is false, then we return 0. That's the first condition of the problem, right? So if our coordinate is on land, then we do nothing. So let's remember now what I talk about regions, and let's make region ID, and okay, first let's make region ID, and let's now say that our point which was searched over doesn't have this region ID -1 but some actual number. So we could check here if starting point dot region ID equals -1 or doesn't equal -1, we can return something else, that already calculated value. And that already calculated value we can keep in something like this dictionary of integer and integer called region surfaces. And let's make a new here. Okay, and first region will have an identifier 0. Okay, so what we will return is basically just region surfaces which are already calculated by starting point dot region ID. See, so if this region was the region 1, this was region 0, region 2, region 3, right? So this will just take its own region which was already calculated and return the result. And now here is the heart of the problem. Now search the area and so flood fill now and calculate the region's surface. Okay, so let's first make some variables. Var surface equals 0. Let me just grab a glass of water. Okay, I'm back. So I grabbed something to eat, grabbed something to drink, and smoked a cigarette, and we are ready for action. So let me show you in Paint how the flat fill will work. Okay, so imagine if we have this, something like this. Like this. This is our map, right? Let's say starting point is here. How does the flat fill work? Well, it checks this 4 fields around him, right? These 4 points. And this point is y plus minus 1. This is y plus 1. It's hard to write here. Let me use the actual text tool. So this is y minus 1. This is y plus 1. And with the same x, right? Same goes here. And here we have x minus 1 and y. And here we have x plus 1. X plus 1 comma y. Okay, so which collection we will use? We will use a queue, and queue is commonly used for solving the BFS algorithm. So breadth first search, meaning something like from starting point you kind of like search in concentric circles around it. So how we do that here? So we will start with the starting point, then these 4 points will be queued up, okay, like this, and then starting when we are done with this one, we will start with this one and it will search its own neighbors, and then to not have this one checked again, we will have to add something to our point. To our point class, and it will be a simple integer called visited. So if we visited a field, we ignore it, and when these are queued up, let's say the next one will from the queue will be this one, and this one will be try to add this, but this one will not be visited yet, but it will still edit, and then this one also not this one, taking this one and this one in. This one will take this one, this one, this one and this one, and you can see how it goes spreading around in concentric circles. And then the next one, will be this one, checking this field, this one that's visited, and then this field, and then this one is next in the queue, and it will mark itself visited, and then add this one, and this one is already visited, and so on. And how do we do that here? So let's first define that queue, and the queue will use coordinates, not the points. We will use coordinates to move around. So let's call it coordinates, let's call it neighbors or something like that. Not neighbors, but coordinate queue equals new queue of coordinate. Okay, and the algorithm will work while coordinate queue dot count is greater than 0, right? Okay, so what do we do first? We get our first coordinate by dequeuing it. Okay, we cannot name it coordinate, but let's say current coordinate is coordinate.dequeue, and then we can check that coordinate, what's happening on it. And one more thing, as we said, we need a bool if this here is visited. If our points are visited. So what we will check is, we'll name it var current point equals map of current coordinate.x and current coordinate.y. IntelliSense helps a lot here. So if that current point dot visited is false and that current point is water, then we will okay, our IntelliSense already knows what to do. We will increase the surface, we will mark that current point dot visited as true, and we will wanna assign its current point dot region ID. Well, what's region ID? Well, the current region ID. And after we are done with this part of the algorithm here, we will want to increase our region ID at the end. Why does it complain? Cannot be assigned to. Okay. Of course, sorry for this. So we can't make this a read only. We need to increase it at a certain point. Region ID, and oh yeah, and here we will just return the surface that we calculated. And now how do we add all the other points in the queue? So for this one I wanna make another method. So let's call this method public, let's say void for now, get neighbors of our coordinate. Okay, so what are our neighbors? We could say if coordinate.x. This seems complicated with the coordinate. Let's just use int x and int y. If our x minus 1 is greater than and equal or equal 0, then it's fine, right? And we can return, oh yeah, we can use again the enumerable for this and yield return each neighbor to make it simpler and easy for us, instead of using some sort of a list at the start and then returning a list. Then we'll yield return it, but this will be enumerable of coordinate yield return new coordinate which has x and y. X is x minus 1 and the y stays the same. And let's do this for x plus 1, and that plus 1 needs to be inside the array, inside of our map. That's why these checks are here, so we don't want to go out of bounds. And this needs to be lower than, I guess, width, because x is over the width. And let's copy and paste this. Okay, sorry, this needs to be plus 1 then. And let's copy and paste this for the y as well. This will stay the same. This will be by the height. This will be by y minus 1. And this will be by y plus 1. Okay, and now we just need to do something like for each var item var neighbor in get neighbors of our current coordinate.x, current coordinate.y. We just need to enqueue them. So coordinate q dot enqueue the current coordinate. Okay, so I'm pretty sure this is already a solution for this. Okay, let's try it out. So I'm not sure what some build errors. Okay, missing parentheses. I'm not sure what should be the solution for this one. Okay, we never printed out solution. Okay, was solver equals new solver from our tools. Okay, and of course our hackerman mode needs to go below this. Our solver, and in our solver we need to send width, height, map, and coordinates. Okay, and now let's just, since our solver has a method all, it's enumerable of integers, let's just use var result equals string.join, and it needs to be separated by a new line, and just solver.solve. Okay, and console write line the result. Okay, it is giving out all the zeros, so something's probably not right, because this point here alone should give us the area of 5. So let's check and see what we messed up here. So coordinate q, we get the current coordinate. We get if it's visited or water, we assign it region ID, we increase the surface, and oh yeah, we never assigned the dictionary, right? So the region surfaces of region ID equals surface. That's one thing. We can add and see, and we can use our debugger to debug something, to debug things as well. Sorry. Come on. Again, all the zeros. So let's try to debug this. Let's see, we are half an hour in. We got some time. I was thinking about maybe an hour of this video. So let's see. Let's first check for the expected output. Can we somehow make... No, you need to have your own output. I think this is the test case. Yeah, found answer, expected 5. Yeah, so let's try to hack it out a bit here to find out our solution for this. Console.writeLine, let's say number 5. Okay, found nothing, expected 0, so the solution is 5 0. Let's see, again, then 3, then 0, and then 4. Okay. Okay, so we hacked this one by just testing out the expected output. So we know that the expected solution is this. Okay, let's add it somewhere here so that we know. Actually, just in the custom. Okay, I play test case. Test case is working. But yeah, so let's try and see by debugging what we did wrong here. Okay, so let's again copy the input. Okay, now starting point is water. Okay, starting point surface, new queue. Oh, we never enqueued our first one, our first coordinate q dot enqueue the coordinate. So let's check again now without debugging what our algorithm will print out. 10101. That's still not correct, so let's go over it again. Let's see what we are missing out here. Okay, starting point surface is 0. We enqueue the first coordinate. We get the current point, which is false, which is water. That's fine. And we increase the surface of it. We say it's visited. We assign the region. We get some neighbor, that is 1 by 1. Another neighbor. Another neighbor. Okay, coordinate q dq. So the current point is visited is equal to true. Okay. Let's see the next one. Did we mess something up here? Let me check my already solved one. New coordinate. So what's going on here in the coordinate queue? 0 by 1, and it just goes over the first element. It doesn't seem to be adding anything else. Let's see. Okay, again. Let's put a breakpoint in here. So the first one is fine, surface is 1. Okay. X and Y are 0, 1. X plus 1 should be 1, 1. Okay. Wait. What's going on here? Let's restart and see. Okay, so we know by this point we are all fine, all good. We yield return one of the neighbors. Okay. Then Y minus 1 is 0, so that's 0, 0, right? And that is 0 and 2. So our coordinate Q should have So I guess the problem is something about the coordinate and creating coordinates like this for some reason. Um, what if we just make it like we did in the past without the constructor? I'm not sure what's the issue now, so I don't wanna go into this, but let's just try to make it so that x equals this and y equals parts 1 and this is part 0 because it's inverted. Okay, and now we will have to return new coordinate x minus 1 and y equals y. Why are we doing this? And let's go here. This is x stays the same, y is y minus 1. X stays the same. This is y plus 1. Okay. Where is our sample? Okay, let's go. Okay. Another one and another one. Coordinate Q. Now let's see, 0, 1, 0, 1, 0, 1. So for some reason it's not working well with the coordinate. I don't know why. Let's make it a class. Let's check again. I'm missing something here that I'm not seeing, but can't tell what it is for now. Okay. Oh, I'm unqueuing the current coordinate instead of the neighbor. Oh boy. Let's just Control Z. Sorry. Control Z back to the beginning. It was all good. Control Y. Like this. Pretty sure it was. Okay. No. We need this one like this now. Sorry. Okay. Now let's check it. And let's see if we get the expected output. And our neighbor is 1 by 1. Okay. Now it's looking good. Our neighbor is not visited. Our neighbor is water. Surface area is great. Okay, let's now make all of these disappear and just go on with the algorithm. First one should have the area of about 5. And let's Let's just make it run. Continue. And let's see the solution, 50304. That's the correct solution. Okay, so yeah, let's now copy and paste this solution to our ID back in here. Okay, we got the point class. We got the coordinate class. So you can't have your file system here, so we'll just copy and paste each class here like this, but you can do this, that's nice. Okay, and our solver as the final piece of the puzzle. Actually, yeah, let's copy and paste it. Okay. And we also need to add our own program. Oh, sorry. Let's format it properly. Play the test case. Tuple must contain at least 2 elements. What? Oh yeah. They don't have a new synthetic sugar support. This test case is working, and let's see all the other ones. Working. Okay. Many lakes. Oh, many lakes. Okay, we are out of bounds with the coordinates. Okay, I think we need to just swap out these two values. Let's do it in our code as well. So yeah, with these problems, you sometimes just swap out the width and height to make things work proper. Let's try it out again. Yeah, now it works. It's hard to think about these, like the x is actually over the height and the y is actually over the width. 100 tests on a 1000 by 1000 map, large lake. Alright, that's it. And let's submit it and see if it works for the other cases which we can't hack. And we learned how to flat fill, memoization and BFS. Let's go over some pieces of code. So we started out, we made the coordinate. The coordinate is this. It's a simple class having x and y. We parsed all the coordinates in the input. We parsed all the points in the input. Some of them are water, some of them are not water. Again, parsed in the input. We created this two-dimensional array for the map, and then in the solver, pretty simple. After assigning everything, solve just goes and does a search for each coordinate, and then for each coordinate, if it's a starting point, if on the coordinate it's not a water, you just return a 0. If we already visited it and assigned it a region, we know that in our dictionary, this is the memoization part, we will already have a solution for it, so we don't search again there. And then we flood fill and calculate the region surface by using the Q and BFS algorithm. Simple as just taking each point out and getting the neighbors with our get neighbors method. And we get these region surfaces. For the region, we increase the region ID for the next one, and we return the surface for each of them. Sounds pretty simple now that we solved it, but yeah, as you can see, you can run into some problems. Simple as like having this here and now rewriting my code instead of using the struct for the coordinate and stuff like that. But yeah, so yeah, thank you guys for watching and see you next time. Bye bye.